Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. I was just waiting for the others to join, but looks like they're not taking up the class today, so we shall get started. Yeah, so continuing from where we stopped in the last class, this is the next one. So here the question is evaluate. Children, I've shared my screen. It's visible, right?
Yes, ma'am.
Yeah. All right. So evaluate 6.389 into 10 to the power minus 24 minus 5.54 into 10 to the power minus 25. Evaluate meaning find the value of. Evaluate meaning we have to find the value of this expression. Okay, so let's see how to do this. So write out what is given. This is the expression given. We need to find the value of this expression. So you can look at this expression as, containing two terms. See, there's one term here, another term here, and they're connected by the minus sign. You need to understand this expression as a difference of two terms. See, this is one term, or you can say the first term, or the first part. Okay, and this is the second part. And the two parts are connected by a minus sign. All right. Now look at the powers of 10 in both the parts. Okay, look at the powers of 10 in both the parts. Minus 24, minus 25. Now, which is the smaller of the two? Minus 24 or minus 25? Which is the smaller of the two?
Minus 25.
Minus 25. So minus 25 is less than minus 24. So what we're going to do is we're going to take out minus 25. That is 10 to the power minus 25 common. That's the idea. The smaller of the two powers is minus 25. Okay, so we are going to take out 10 to the power minus 25 common. That's the idea. So we prepare for that. All right, so how do we prepare? Now this power is minus 24. We write this in terms of minus 25. That is using minus 25. The first step is to understand the expression given. We understood that the expression is made up of two parts connected by a minus sign. In both the parts, we have 10 raised to some power. In the first part, it is 10 raised to the power minus 24. In the second part, it is 10 raised to the power minus 25. The smaller of the two powers is minus 25. So we have to take out 10 to the power minus 25 common. For that, what you have to do is you need to write this 10 to the power minus 24 using minus 25. Using minus 25. So minus 25 and what will give you minus 24? Minus 25 and what will give you minus 24? So minus 25 plus 1. Minus 25 and plus 1 is minus 24. Is minus 24. So we write minus 24 as minus 25 plus 1. See that power, the same thing. The others are the same. We simply write this power minus 24 as minus 25 plus 1. Why minus 25? Because we are going to take out minus 25 common, 10 to the power minus 25 common. So we write minus 24 as minus 25 plus 1. Now the next step is 10 to the power minus 25 plus 1 can be written as 10 to the power minus 25 into 10 to the power 1. Why? Because we know when bases are same and it's multiplication, we have to add the powers. So we are trying to write the earlier step, the previous step. See, you have 10 to the power minus 25 plus 1. We are trying to, recreate the earlier step. The earlier step, it would have been 10 to the power minus 25 into 10 to the power 1. So here, bases are same, 10, and it's multiplication. So we add the powers, minus 25 plus 1. So we write the earlier step, 10 to the power minus 25 plus 1 can be written as 10 to the power minus 25 into 10 to the power 1. The earlier step. This one as it is. This one is 10 to the power minus 25 into 10 to the power 1. The second part as it is there. As it is there. Now we are ready to take out 10 to the power minus 25 common. Now take out this. 10 to the power minus 25 is common in both the parts. So if you take out this common, 1 second, I'm just getting a call. Just a second. Yeah, thank you, children. So now take out 10 to the power minus 25 common. So in the bracket for the first term, we have already brought this one out. So don't write this. Write the remaining 6.389 into 10 to the power 1. So you know that 10 to the power 1 can just be written as 10. So that's what you see here. You can see this one into 10 minus. This is the second part. Here also this is common. So write 5.54. 5.54. In the two parts, this is taken out common. So write the remaining 6.389 into 10 to the power 1, which is nothing but 10 minus 5.54. Now, in the next few steps, 10 to the power minus 25 comes as it is because we are busy simplifying the terms in the bracket. Okay. So now simplify this. So it is 6.389 into 10, which is 63.89. 63.89 minus 5.54 will give you 58.35. Now, you can see in the next step, I've just written this one first and then I've written this. I've just written this one first, 58.35 into 10 to the power minus 25. Now, what is the next step? How do we know that we have simplified it completely? The last step or the final step should be in the scientific notation. It should be in the standard form. Now, just judge this answer. Is it in the scientific form? No, because the first part is more than 10. The second part is 10 to the power some integer. The second part is fine. But the first part, we know can be 1 or anything more than 1 but less than 10, but clearly this is more than 10. So if you think this, meaning if we stop here, this one is not in the scientific notation, which means we have to continue to write the answer in the scientific form. So now again, don't disturb this one as it is. Now write this one in the scientific form, 58.35. Okay, so you'll have to move the decimal point one place to the left. So it becomes 5.835 into 10 to the power. The number was 58.35. We have reduced it to 5.835. You have reduced the value of the number. So decreased. So increased, meaning raised into a positive power. You have shifted by only one place, so plus 1. So 58.35 is nothing but 5.835 into 10 to the power 1. Now you can simplify these two because bases are same and it's multiplication. So you need to add the powers. So you see here, we add the powers. And the final answer is 5.835 into 10 to the power minus 24 because 1 plus minus 25 is minus 24. Is that understood, children?
Yeah, ma'am.
Okay. Now, it is not mandatory that you have to take out minus 25 only common. You can also work by taking 10 to the power minus 24 common. It's not wrong. But sometimes, children get confused as to which one to take out common. So I said take out the smallest power common. You can do that always. You can always do that. You can take out the smallest power common always. However, you can take out any of it common. You can also take out 10 to the power minus 24 common and work it. You will get the same answer. The final answer will be the same. Yes, so today in the meeting we have Gayatri, Lakshana, Ariston, Aishwarya, Netra, and Shreya. Aishwarya Shri is not there and Anantika is not there. And one more
Sai
person.
Smriti, ma'am.
Oh yeah, Sai Smriti. Right. Sai Smriti. Three of them are not here today. All right, children, please let me know anywhere. You can ask me any question. Anywhere you don't understand, children, please ask me. Okay, now please write down this in your book. And also, I want all of you to try working the same sum by taking out 10 to the power minus 24 common. And whoever is confident to read out those steps can read it out for me. Otherwise, I'll work it for you. I'll not force anyone to, share their answer. If you're confident, if you don't mind sharing the answer, because see, in this platform, you're not judged. In my classroom, no child is judged. All of us can see. If you don't work it today, you will learn it today. Either you're going to do it by yourself or you're going to learn it at the end of the session. So you can just feel free to share whatever comes to your mind. But again, if you're hesitant to share your answer, I can work it for you. So your task now is to write down this answer in your notebook and also try the same question by taking out 10 to the power minus 24 common. Is that fine, children? Got my question? Children, say yes or no. What happened? Am I not audible? Gayatri, am I audible? Lakshana, Ariston, Aishwarya, Netra.
Ma'am, I'm audible.
Okay, yeah. Please work this. Done, children? Why today there is no response? Huh? Such an active class always. What happened? Is it boring?
No, ma'am.
Okay, children, please, it cannot be a monologue. There should be interaction, right? To make the class interesting. Yeah, please tell me, have you finished writing this in your book?
Yeah, ma'am.
Okay, who wants to share the alternate working with me? Taking out 10 to the power minus 24 common. Nobody? Okay, fine. So the question is 6.389 into 10 to the power minus 24. 6.389 into 10 to the power minus 24 minus 5.54. No, sorry, 54. All right. So here we want. Yeah, please. Yes.
Ma'am, so it's 6.389 into 10 to the power minus 24 minus 5.54 into 10 to the power minus 24 minus 1.
Very good. Minus 24 minus 1, which is minus 25. Perfect. Yeah, next step.
Step is 6.389 into 10 to the power minus 24 minus 5.5.
Yeah, 5.54
into 10 to the power minus 24 into 10 to the power minus 1.
Perfect. Next.
10 to the power minus 24, open bracket, 6389 minus
6.389
minus 5.54 into 10 to the power minus 1.
Very good. Next.
10 to the power minus 24, open bracket, 6.389 minus 5.54 into 1 by 10.
Very good. Into 1 by 10. Very good. Yeah, next.
10 to the power minus 24, open bracket, 6.389 minus 5.54 into 0.1.
Into 0.1. That is, you are writing 5.54. Sorry, 1 by 10 is 0.1, is it?
Yes, ma'am.
Okay. But is 1 by 10 0.1?
Yes, ma'am.
Okay, you're sure about that?
Yes, ma'am.
Okay. Okay, so that's also that's correct. So 5.54 into 0.1. That's fine. Or you can also write it's also 5.54 by 10, right? By 10. Okay, you're right. You're right. You would have also got the same thing. 6.389 minus, or shift the decimal point. What is 5.54 by 10? It'll be 0.554. You'll have to move the decimal point to the one place to the left. Here also, when you multiply, you'll get the same result. You're right. Lakshana, you're right. You can write 1 by 10 as 0.1 and multiply 5.54 and 0.1. Or you can also write it as 5.54 into 1 by 10 is nothing but 5.54 into 1 is 5.54 by 10. By 10. Yeah, very good. Yes, next.
Ma'am, next step is 10 to the power minus 24, open bracket, 5.835, and which can also be written as 5.83.
No, 1 minute, you're too fast. 1 minute. What is the difference? What is 6 point, what's that, 389 minus 0.554? What's the difference you got?
Ma'am, it's 5.835.
Okay, fine. All right. Yeah.
And which can also be written like 5.835 into 10 to the power minus 24.
So that's nothing but, sorry. That's nothing but 5.835 into 10 to the power minus 24. And is this in the scientific form or the standard form? Lakshana is the final answer in the scientific notation?
Yes, ma'am.
Yeah, because the first part is less than 10, it's more than 1 and less than 10, and the second part is 10 raised to an integer power. Very good, Lakshana. I'm sure all of you, I understood what Lakshana said. I'm sure all of you understood. Please practice this.
Yeah, ma'am,
Yeah.
I understood, but I was a bit confused at some points, like particular place where you multiply it all. That's why.
Yeah, correct. I'm sure you have, so it's okay to have a problem here. It's okay. But you understood now?
Yeah, I understood, ma'am.
Yeah, no, is this the place where you had a problem to simplify? Or maybe you were stuck here after 10 to the power minus 1, maybe we did not know how to proceed, right?
I was actually, yeah.
Yeah, no, that's fine, that's fine. Now you understood? 10 to the power minus 1 is 1 by 10. Is that clear? Any questions now? Gayatri, Ariston, Aishwarya, Netra?
This is Aishwarya. I was actually confused at the step where you subtracted with 10 to the power minus 24, but then now I understood them.
All right, dear. Very good. No questions now, Aishwarya?
No questions.
No one understood.
Okay, so the next one is a test, children. Yeah. Please make a note of this because for those who could not try it, it's still fine. Write down this answer, children.
Done, ma'am.
Yeah. All right. Next one. So here, which is the least power, children? 15 or 18? Which is the least power?
18, ma'am.
Least power.
15.
15, ma'am.
15. 15. So how will you write 18? You will write 18 as? Fifteen is the least power. So you will have to write 18 as what? 15?
3, ma'am.
15 plus 3. 15 plus 3. Or if you take out 18 common, you can even do that. I told you. You can even take out, see, preference is not preference like Okay, so let me say preference. Preferences take out the smallest power common, but you can also take the greater one common. So if you have to take 10 to the power 18 common, then you will write 15 as what? Yes, 15 will be?
15 plus 3, ma'am.
No. You want to take 18, 10 to the power 18 common. So you must write 15 using 18.
I don't understand, ma'am.
No. If you have to take out 10 to the power 18 common, 10 to the power 18 is 10 to the power 18. You should write 10 to the power 15 using the number 18. So how will you write 15 using
10 to the power 18 minus 3?
Yeah, 10 to the power 18 minus 3. See, you want to take out 10 to the power 18 common. Then you must write the other one. That is 10 to the power 15 using 18. Using 18, how will you write 15? Using 18. 18 minus 3 is 15. Yeah, do this, children. First, you work by taking 10 to the power 15 common. Do it. Let me know if you're finished, children. Yeah, done, children. Yes, Gayatri, read out your steps. Gayatri. Ariston.
Ma'am, I'm not done it.
It's okay. Whatever little you've worked, you can share with me.
Okay, fine.
Yeah. Netra. Oh, Gayatri, you have texted that you're speaking, but I'm not able to hear you. Oh, I'm sorry, Gayatri. Please check your mic and your speaker. Yeah. Nobody wants to share, children?
Ma'am, I'm not done, but can I share?
Yeah, yeah.
So 10 to the power, so this changes, so the power changes to 15, 10 to the power 18 minus 3.
Yeah, no,
So
you just read out what is in your book. Just read out what you've written.
that's
So
what
5.965 into
10 to the power into 10 to the power 15 or 18 minus 3. That's how I've written.
no, what have you changed? 15 or 18? Which one have you changed?
I've changed 18, ma'am.
Yeah, then continue. Plus 39.46 into 10 to the power.
18 minus 3, ma'am.
How can you write 18 as 18 minus 3? 18 is not 18 minus 3. What is the other way of writing 18 using 15? You should not change the value of the power.
Okay, ma'am.
See, 18 is 18 only. There are different ways of writing 18. You can write 18 as 10 plus 8. You can write 18 as 20 minus 2. You can write 18 in so many other ways. You need to write 18 using 15. So how do you write 18 using 15?
15 plus 3.
Yeah, that's all. 15 plus 3. You cannot write 18 minus 3. See, the power is 18. 18 should remain 18. 18 cannot become 15. The power is 18. The power should be 18 only. You're writing 18 in a different way. Instead of 18, you're writing 15 plus 3, which is still 18. You cannot write 18 as 18 minus 3. 18 minus 3 is 15, but the power is 18. So the power 18 is 18 only. You're writing, there are so many ways of writing 18. And one of the ways is 18 is 15 plus 3. See, 15 plus 3 is 18 only. Yeah, so in the next step, 5.965 into 10 to the power 15 plus, continue. You may not have these steps in your book, but you can tell me now. 39.46 quickly into
10 to the power 15 plus 3.
no, why again 15 plus 3?
Then we can write it as 18, ma'am.
No, no, no.
I still don't get it, ma'am.
Yeah, no problem, no problem. All this comes only with practice. Yeah, so now we write 10 to the power. Who can say 10 to the power 15 plus 3 should be written as? What's the previous step? 10 to the power 15 plus 3. What will be the earlier step? 10 to the power 15 into
10 to the power 3.
10 to the power 1.
yeah, 10 to the power 15 into 10 to the power 3. 10 to the power 15 plus 3 is nothing but 10 to the power 15 into 10 to the power 3.
Yes, ma'am.
See, we write 10 to the power 15 plus 3 as 10 to the power 15 into 10 to the power 3. So when base are same, it's multiplication, you add the powers. Now we take out 10 to the power 15 common. Continue, Shreya.
Ma'am.
Yeah.
Then in the brackets, you should add them both. 5.965 plus 39.46.
That's all.
Into 10 to the power 3.
Yeah. Next.
Then next, you have to add them all.
Not add them all. Now this into 10 to the power 3 is for 39.46, right?
Yes, ma'am.
Yeah, so simplify this. What is 10 to the power 3,000, right?
Yes, ma'am.
Yeah, so into 1,000.
Okay, ma'am.
Yeah, so what is it? What is 39.46 into 1,000?
Is it 39,000, ma'am? I'm sorry, ma'am. I'm just in a confusion right now.
Yes, yes, no problem. Okay, fine, fine. It's so nice, you still want to say something. That's appreciated, Shreya. That's how we learn. You have to speak your mind. Only then I can understand how I can help children better. Thank you for your participation. I'll wait for a minute. Please get back, Shreya.
Okay, ma'am.
Yeah.
Mom, this is Aishwarya. I'm actually getting the answer as a pretty big number, so I'm gonna just work it out again.
Have you got the step so far? Have you got it right?
Yes, ma'am, so far it's right, but then
Meaning
during
so
the
far, meaning to the extent I have worked. Have you got the same steps?
yes, ma'am, and I think I've written like 1 or 2 steps after that also.
Okay, fine. Okay, let me see how you have continued. So what is 39.46 into 1000?
Ma'am, I got it.
Yes, Shreya?
39,460, ma'am.
Yeah, correct. Then what's the sum? That's right. 39.46 into 1000 is 39,460. That's right. Then find the sum. Now add these two.
Just a second, ma'am.
Yeah, yeah.
Ma'am, I'm back.
Yeah.
The answer is 39,465.965.
Perfect. So this is nothing but 39465.965 into 10 to the power 15. Now ask yourself if this is in the scientific notation. Is it in the scientific notation? The second part is fine, 10 to the power 15, but the first part is way more than 10. So write this in the scientific form. Write the first part, 39,465.965 in the scientific form. So bring that number in that range 1 to 10.
Yes, ma'am.
Yeah.
3.9465.
3.9465965. Don't forget that.
Yes,
Into
ma'am.
10 to the power
10 to the power 3, ma'am.
check.
No, ma'am. I'm sorry. I'm sorry. 10 to the power 7, ma'am.
No, see, the decimal point is here. Okay. 1, 2, 3, 4. 4. So is it a positive 4 or a negative 4?
Positive 4?
No, you must not ask. You must say.
I don't know, ma'am. If I get confused with one thing, I get
Yeah,
so.
it happens. The mind gets completely blanked out, and even the simplest of the simple things, we are not able to say. That's fine. That's fine. Yeah. So now the thing is, the number was 39,465 point something. Such a big number. We have shrunk it to 3.9465 and something. So 39,000 has become 3 point. So we have reduced the value, meaning decreased the value. So raise 10 to a positive power, give the opposite effect. If you decrease the value, increase. No, the opposite thing is increase, meaning a positive power. So plus 4 it will be. If you decrease the value, raise 10 to a positive power. If you increase the value, raise 10 to a negative power. Somebody's mic is enabled. Disable your mic. Ariston, disable your mic. Yeah. So it will be 3.9465965 into 10 to the power 4 into 10 to the power 15. Correct?
Ma'am, I have a doubt. Why should we add 10 to the power 15 to that?
No, that's already there. No, so we're writing it. See now, if you have to do this multiplication, 2 into 3 into 4. What is 2 into 3? 6 into 4. So you have like, it's like asking why into 4. That into 15 is there, no? So we're just getting it down. Yes or
Okay.
no?
Yeah, ma'am. Now I understood.
It's there. We are not writing, we are not introducing that. It's already there in the earlier step and we write it down. See, it's here, no? This 10 to the power 15 is here. Yeah.
Got it, ma'am. Thanks.
Yeah. So after this, bases are same and it's multiplication. So we add the powers. Okay, so let me continue here. So that is equal to 3 point. Now you don't have to write so many digits after the decimal point. You can just write only up to 2 or 3 decimal places. So you can start with 3.946. 3.946. It's okay if you write everything, but you can limit it to 2 or 3 digits after the decimal point. So 3.946 into, or if you want, you can also make the 6, 7, because when you round off, this one increases to 7. But that's okay. These are, trivial things. So you can just ignore it also. You can you can write it as 3.946 or 3.947 by rounding off. Okay, so anything is fine. So say 6 or 7, I told you, into 10 to the power 4 plus 15. So the final answer is 3.946 into 10 to the power 19. And you can see that the final answer is in the scientific form or standard form. Take it down, children.
Done, ma'am.
Yeah. Others?
Yes, ma'am, done.
Okay.
Done, ma'am.
All right. Children, if you, sometimes the internet connection is best at a particular, place in the house, maybe the living room or, in some particular room. In that case, children, if your family members are there sharing the room with you, please use a headphone, because when you unmute to talk, the background, noise that cannot be avoided, but if you use a headphone, I think that'll be better. If you're sitting alone in a room and there is no background noise, you don't have to use one. But otherwise, it is very important. It becomes necessary because you want to say something, but then there is noise from the background, and so you are not comfortable talking. Yes, children. So the homework is to do the same sum, taking out 10 to the power 18 common. We'll not do it now. It will become boring, like we've been doing this for the last 1 hour. So try this as homework, taking out 10 to the power 18 common. Here we've taken 10 to the power 15 common. Take out 10 to the power 18 common and work the same sum. All right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. Yeah. Look at this question. Mass of Earth is 5.97 into 10 to the power 24 kilograms, and the mass of moon is 7.35 into 10 to the power 22 kilograms. What is the total mass of the two? Now, what operation will you use here? Addition, subtraction, multiplication, division. What operation will you use here?
Ma'am, addition.
Addition. So the total mass will be the sum of the two expressions, 5.97 into 10 to the power 24 plus 7.35 into 10 to the power 22. And we just learned how to add such expressions. We just learned how to add such expressions. Now the same thing is in the form of a word problem. Here we just had it as a question like this: find the value of. Find the value of. Here it's in the form of a word problem. The mass of the earth and moon are given to you. You'll have to find the total mass of the two. So you'll have to add these two expressions. Can we do this, children? What will you take out common? 10 power 22 or 10 power 24?
10 power 22.
22. So you will write 24 as what?
10 power 22 plus 2.
Yeah, 20. Yeah. So 24 should be written as 22 plus 2, which is still 24. So you must write 24 as 22 plus 2. What is 22 plus 2? 24. So 22 plus 2. And in the next step, you must write 10 to the power 22 into 10 to the power 2. Because we know when bases are same, it's multiplication, we add the powers. 22 plus 2, this step, 22 plus 2. Yes, children, do this. But you must present the statements also. Let me begin, write the first two steps, the initial steps for you, and then you can continue. So you start like this: mass of.
Excuse me, ma'am, do we have to leave space for the homework or can we just do it at the end?
Yeah, leave some place, no? Leave some place, yes.
Okay.
Yeah. Yes, children. Please start like this. Yeah. I've got you started. Now finish. And children?
No, ma'am.
I'm still working it out. Just a few minutes.
Okay, okay. Yeah, yeah, yeah. Please, please.
Yes, I'm done.
Done, ma'am.
Yeah. Yeah. How do I continue?
So you have to write 5.97 into 10 to the power 22 into 10 to the power, plus 10 to the power 2.
No, not plus.
Sorry, into 10 to the power 2 plus 7.35 into 10 to the power 22.
Okay.
Then you have to take the common, which is 10 to the power 22. Open brackets, 5.97 plus 7.35.
No. Not plus. No.
5.97 into 10 to the power 2 plus 7.35.
Yeah.
So then it will be 10 to the power 22 in brackets, 597 plus.
Okay. Yeah, you're right, but I just want to give the step. So in plus 7.35. Correct, you're right. So
Yes,
this
ma'am.
product will be 597 plus 7.35. Correct. Next.
So I did it the other way, so I'm just gonna add it. 1 second.
No. What is that other way you did? Read out.
Ma'am, actually, I thought that 10 to the power 2 should come at the end. So for me, at the end, it was 5.97 plus 7.
Yeah, we both did the same way, ma'am.
Yes, ma'am.
No. 10 to the power 2 in the end means after 7.35. Is it?
Yes, ma'am.
Okay. So this is the first part and this is the second part. So in the first part, if you write 10 to the power 22 common, what are the other things remaining? 5.97 into 10 square, right?
Yes, ma'am.
Then this plus, in the second part, 10 to the power 22 is out common. So the remaining thing, 7.35. Isn't it like that?
Yes, ma'am, it's like that.
Yeah, now 10 square is 100. So 5.97 into 100 is 597 plus 7.35. Now what is the sum of the two?
1 second.
Ma'am, is it 13.32?
The sum is 13.32, is it?
Ma'am, I'm getting it
I did
as
the other way.
604.35.
Correct. 604.35. 597 plus 7.35. 597 is 597.00 and 7.35. So
Yes, ma'am.
604.35.
Yes, ma'am.
Yeah. Now this answer, the step, the last step which we have now is not in the standard form. So we need to proceed to write the last step in the standard form. So that can be written as 604.35 into 10 power 22.
Which will be 6.0435
Yeah,
into 10 to the
correct.
power 22.
6.0435 into 10 to the power. You've reduced the value. 604 has become 6. So positive power, positive 2.
Yes, ma'am. Positive.
And the 10 power 22, which is there, write it down again. So now this is 6.0435 into, based on the same, it's multiplication, add the powers. So 2 plus 22.
10 power 24.
Yeah. Very good. Yes, children, please complete. Somebody's mic is enabled. Please disable your mic.
Done, ma'am.
Yeah. All of you?
Yes, ma'am. Done.
Yes, ma'am. Yes, ma'am.
All right.
No, ma'am, I'm still writing.
Okay. Yeah, Nantika, fine.
Ma'am, the working on the side is the continuation of the working.
Continuation. Yeah, correct. It's a continuation. Yes.
Ma'am.
Yes.
Ma'am, it was before 604.35. How did it change to 6.0435?
Yeah, 604.35 in the standard form.
Okay.
Yeah.
Done, ma'am.
Yeah. All right. There's the next one. So Anantika, I'll share the recording. I think by
Yes, ma'am.
10 o'clock, I'll share the recording. Please watch the first part. That is to the extent you have missed today, make sure that you watch that and write down the contents in your book. All right.
Yes, ma'am. Sure.
Yeah. All right. So the distance between the sun and earth is 1.496 into 10 to the power 11 meters. And the distance between the earth and the moon is 3.84 into 10 to the power 8 meters. During the solar eclipse, the moon comes between the sun and the earth. At what? Sorry, at that time, what is the distance between the moon and the sun? You can see here. Now it's given that during the solar eclipse, not it's given that we know that during the solar eclipse, the moon comes between the sun and the earth. So you can see the diagrammatic representation here. The moon between the sun and the earth. During solar eclipse, the moon comes between the sun and the earth. You can see here the moon between the sun and the earth. Now let's represent the distance here. The distance between the sun and the earth. You can see here the distance between the sun and the earth. So sun and earth, the distance between the sun and the earth, this distance I've marked here. And the distance between the earth and moon, earth and moon, earth and moon. So now the question is to find the distance between the moon and the sun. Moon and the sun, you'll have to find this distance. This distance. So it's like we have 3 points A, B, and C. We have 3 points A, B, and C. Okay, A, B, and C. Now the distance between AC is say 20 kilometers. And the distance between AB is 7 kilometers. Then what is the distance between the points B and C? If the distance between the points A and C is 20 kilometers and A and B is 7 kilometers, what is the distance between the points B and C?
Almost 13 kilometers.
13. 13 because 20 minus 7. The total distance 20 minus 7. 13 kilometers. Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yeah, ma'am.
Agree all of you?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yeah. So in the same way, the distance between the moon and the sun. So this is E. Okay, so let's say this is E, this is M, and this is S. The total distance is known. The total distance is known. And this distance is known. You need to find this distance. So it is this one. It is this whole distance minus this distance. So the distance between the moon and the sun is the whole distance 1.496 into 10 to the power 11 minus 3.84 into 10 to the power 8. That's it. And now you know how to subtract. So I'm taking you to the, I'm not showing you this working. I want you to do this by yourself.
Ma'am, should we also draw a diagram as you have?
Yeah, correct. Yes.
Okay, ma'am.
Okay, children, I'll, like present the slide, but I don't want you all to blindly copy the answer from the screen. Please do it by yourself. And once you're done, you can check your answer, your steps with what you see on the screen. Please write the question, take the diagram, and then work the answer.
Ma'am, the diagram is noted and so is the question.
Anantika, come again.
I just said that I have noted the question and the diagram.
Yeah, okay. Done, children?
Yes, ma'am.
No, ma'am, almost done.
Okay.
Ma'am, a few more minutes.
Ma'am, the answer, how did you, from 10 raised to the power 8, how did you get 10 raised to the power 3 into 10 raised to the power 8?
Again, that number 1492.16 when expressed in the standard form.
Okay, ma'am.
Yeah, becomes 1.49216 into 10 cubed.
Done, ma'am.
Yeah. All of you?
Yes, ma'am.
Okay.
Yes,
All
ma'am.
right. The size of a red blood cell is 0.000007 meters. And that of a plant cell is 0.00001275 meters. Okay. Show that a red blood cell is half of a plant cell in size. Show that a red blood cell is half of a plant cell in size. So the sizes of a red blood cell and a plant cell is given to us. We need to show that. So supposing the size of the first one, for example, it's like 5 meters. Okay. And the size of the plant cell says 10 meters. So what is the size of 1 minute? Yeah. Excuse me. Yeah. So what is the size of a red blood cell by the size of a plant cell? 5 by 10, right? Please help me, children. Is it 5 by 10 or no?
Yes, ma'am.
Yeah. In our example, if it is 5 meters and 10 meters, then the size of RBC by size of the plant cell is equal to 5 by 10. Because RBC is 5 meters, plant cell is 10 meters. So 5 by 10. So which simplifies to 1 by 2. So what do you get? Size of red blood cell by size of plant cell is equal to 1 by 2. On cross multiplying, when you cross multiply, you get size of red blood cell is equal to half the size, half into size of plant cell. See, like you have A by B is equal to C. When you cross multiply, you get A is equal to C into B. Excuse me. I'll just have some water and get back, children. Please wait. Yeah, children, thank you. I'm back. So I was telling you, if this we assume to be 5 and this is 10, then the size of RBC by the size of a plant cell will be 5 by 10, which can be reduced to 1 by 2. Upon cross multiplying, we get RBC is equal to half of PC. That is the size of a red blood cell is half the size of a plant cell. This is exactly what we have to do here. We need to start with this ratio. We need to start with this ratio, size of RBC by size of plant cell. Work, and upon cross multiplying, you should be getting this result. RBC is equal to half of PC. So when you put this equation in words, it means the size of a red blood cell is equal to means is half the size of a plant cell. If you read this in words, if you read this mathematical statement in words, RBC by PC is equal to 1 by 2 on cross multiplying. RBC is equal to half of PC. So read this, the size of a red blood cell is half the size of a plant cell. Half of the size of a plant cell, because half into means off. Half of the size of a plant cell. That's exactly why we start like this. So size of RBC, am I clear, children? Shall we start?
Yes, ma'am.
Yeah.
ma'am.
Yeah.
Yes, ma'am.
So we start working like this. Size of RBC by size of plant cell is equal to whatever values are given. Whatever values are given. Next step, express both the numbers in the scientific notation. Express both the numbers in the scientific notation. So in the numerator, the number is so small, it's 0 point something. So you have to shift the decimal point like this: 1, 2, 3, 4, 5, 6. So it becomes 0, 1, whatever, so many zeros, and then 7. And here the decimal point. So it's nothing but 7. These zeros have no value. So it's just 7. See here, 1, 2, 3, 4, 5, 6. So then the number becomes 7. Once you move the decimal point to this place, children, 2, 4, 5, 0. So see here, 0, 1, 2, 3, 4, 5, 0, 7. The decimal point from here, it moves here. So then this number is only 7. So 7 into. So what have we done? It's such a small number. It was just 0 point something. We have increased its value to 7. So raised into a negative power. You've increased its value already. Then don't raise it into a positive power. You've already increased its value. So raise 10 to a negative power, negative 6, because we moved the decimal point to the right by 6 places. Divided by the same thing here, 1, 2, 3, 4, 5. When you move the decimal point to the right by 5 places, you get the number 1.275. Which is clearly more than 1, less than 10. It can be even 1. 1.275 is more than 1 and less than 10. And you get this number 1.275 by shifting the decimal point to the right by 5 places. So it's a small number. You've increased its value to 1 point. It was 0 point. It's become 1 point. So negative power. All right, children. Is the first step understood? So in the first step, we write the numbers in the scientific notation. That's the first step. Now after this, we write this number 7 as it is, 1.275 as it is. We use the law of exponents. What does the law say? When bases are same and its division, we subtract the powers. So base 10, and its division. Its division. Base 10, and it's division. So we subtract the powers. So it becomes 10 to the power minus 6 minus 5. Minus 6 is the power, minus 5 is another power. You need to subtract the powers. So take a minus sign in the middle. Minus 6 minus 5 are the powers. Take a minus sign in the middle because you'll have to subtract the powers. So that's the next step. So then again, 7 and this 1.25, they come down as they are. And this is minus 6, minus into minus is plus 5. Now minus 6 plus 5 is minus 1. Continuing, okay? Continuing here. So this 7, you can see here, 7 and 1.5, they just keep coming as they are. We're just working with this one. Minus 6 plus 5 is minus 1. 10 to the power minus 1. Now 10 to the power minus 1. So if you want to make, the power positive, when you're working, when in places like this, children, I'll tell you the easier way of making the power positive. Just change the position. If the number is in the numerator, bring it to the denominator. If it's in the denominator, take it to the numerator. Then the power will become its opposite. Minus 1 can become plus 1. Plus 1 will become minus 1. Ten to the power minus 1. You want to make the power positive. Just change the position. It's in the numerator. Take it down to the denominator. Minus 1 will become plus 1. Why? Because what is the equivalent of 10 to the power minus 1? We need to take the reciprocal of the base and the negative of the power. So it's 1 by 10. So that means the 10 comes down. 1 by 10. 10 to the power minus 1 is nothing but 1 by 10. So 10 comes down. Remember this. If the power is negative, see, supposing you had 10 to the power minus 3 in the denominator. Okay. Now you want the power to become positive. It's in the denominator, right? So take it away from the denominator, take it to the numerator. So minus 3 will become plus 3. If you just change the position, there are only two positions here, numerator, denominator. So supposing we have 10 to the power 5 in the numerator. If you have to write it in the denominator, it will become into 10 to the power minus 5. Plus 5 will become minus 5 if you change the position. Okay, so 10 power minus 1. If you take it down to the denominator, it will become 10 to the power plus 1, which is 10. Now 1.275 into 10 is 12.75. Now I want to get rid of the decimal point. I don't want this 12.75. I want to get rid of the decimal point. And that you can do by multiplying the numerator and denominator by 100. See, you have 7 by 12.75. You don't want this decimal point. You want to get rid of it. So that can happen by multiplying the denominator by 100. 12.75 into 100 is 1275. But whatever you do to the denominator, you should do the same thing to the numerator. Equivalent fraction. Do the same thing to the numerator and the denominator. Because when you multiply and divide by 100, it's like cancels and 1. So you're not actually doing any change. See here, 100 ones are 100, 100 ones are 100. So it's like you're multiplying by 1. So now 7 into 100 becomes 700 and 12.75 into 100 is 1275. And when you simplify this, in the tables of 7, not 7, sorry, 4, in the tables of 4, whatever, I'm not sure. So whatever you simplify, when you simplify, you get 28 by 21. On simplifying, you get 28 by 21. Now, 28 and 20, 28 by 51. I said 21, I think. When you simplify, you get 28 by 51. Now, 28 by 51, children. See here. When you divide this, when you divide 28 by 51, I'm using my calculator. I'm getting, when I divide 28 by 51, I'm getting 0.549. It goes on like that. Okay, 0.54. You can just divide up to 2. See, divide 28 by 51. So it's not possible. So 0 point, add a 0 here. 51 5 times is 255. And the remainder is 25. Add a 0. Correct? Add a 0. 51 4s are 204. And then what's the remainder? 46 is the remainder. Add a 0. So it goes on like this. So you get 0.54. 549. I did it with the calculator. So 0.549. It goes on. The division does not come to an end. It goes on. So we just stop here when we get 2 or 3 decimal places. Okay. So anyways, it is 0.5. And we know that half is 0.5, right? Half is 0.5. So on dividing, excuse me, on dividing, you get 0.5 and 0.5 is nothing but 1 by 2 because 0.5 is 5 by 10, which is 1 by 2. So that's what we wanted. We wanted to get 1 by 2. Now on cross multiplying, when you cross multiply, size of RBC is equal to half into size of plant cell. That means what? Size of red blood cell. Size of red blood cell is equal to half the size of a plant cell. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah, so I said start like this. Start with size of RBC by size of PC is equal to, write the values given. Then express the numbers in the numerator and denominator in the scientific notation. That's the next step. And then write these two numbers as they are. Use the law of exponents. When bases are same and its division, we subtract the powers. So write the powers -6 and -5. Take a minus sign in the middle. You'll have to subtract the powers. So that becomes -6 plus 5, which is -1. Now, since we have to find the value, you don't want a negative power. You want to make it positive. So I said, now this one is in the numerator. If you write it in the denominator, the power will take the opposite sign. So it is 10 to the power -1. If you bring it down to the denominator, it will become 10 to the power +1. See, using the same rule, children, using the same rule, how do you write the equivalent? What is 10 to the power -1? It's reciprocal of the base.
Yes, ma'am.
And negative of the power. So 1 by 10. 10 to the power -1 is 1 by 10. So that's what it is. 1 by 10 into 1 by 10. Okay. Now multiply the denominators and you get this. Now you want to get rid of the decimal point. So you multiply the numerator and denominator by 100. And finally we get this. Simplify. So let me check which tables I've used. First in the tables of 5. 5 1s are 5, 2 remains. 5 4s are 20, 0. 5 2s are 10, 2 remains. 5 5s are 25, 5 5s are 25. Again, the tables of 5. 5 2s are 10, 5 8s are 40. 5 5s are 5 1s are. So in the tables of 5, 2 times. In the tables of 5, 2 times, when you simplify, you get 28 by 51. Now we actually divide 28 by 51. We actually divide. And the division does not come to an end. So we get 0.549. It goes on like that. So you can find up to 2 or 3 places. That's enough. 2 or 3 places enough. So
Ma'am,
0.
but you have only taken it in one place. So you have told 0.5 or 1/2 approximately.
Yeah, that's because we need to get half right and we already got it here. 0.5 is half. So I stopped there. Okay.
Yeah.
Yeah, you can you can maybe perform the division and show that it is 0.549 is equal to 0.5. You can maybe include that. I started 0.5 because 0.5 is half. That's enough for us. This is an approximation. So it may not be exactly half. It can be a little more than half also. So it is roughly about just an estimate. That's all. It's not an accurate thing. Approximately.
Yes, ma'am, got it.
Yeah. So 0.5, which is 1 by 2, because 0.5 is 5 by 10, which is 1 by 2. So now we got 1 by 2. Now we are ready to cross multiply. So when you cross multiply, so I told you A by B is equal to C. So when you cross multiply, it is A is equal to C into B. So half into size of plant cell, which means the size of red blood cell is half of the size of a plant cell. And that's what we had to prove. Is that fine, children?
Yes, ma'am.
All right.
Will we do MCQs now?
Yeah, Anitika?
Will we do MCQs now?
No, I'm just, yeah, that's what I've just opened my planner. Just a minute.
Okay, ma'am.
Yeah, no. Yes, children. Somebody's mic is enabled. Please disable your mic. So let's see how we can answer this one. Okay, we need to solve for x. Find x. The question is find x. So what is given? 2 to the power x plus 2 to the power x plus 2 to the power x is equal to 192. Yeah, I'll wait for a minute. Let me see if you can help me proceed.
Ma'am, after the B part, can we also try the A part?
Yeah, yes.
Okay, ma'am.
Yeah. I'm just working from behind. Yes. Any idea? Let me ask you something. What is 5 plus 5 plus 5? Don't say 15. Don't say 15. What's the other way of, like expressing 5 plus 5 plus 5?
10 plus 5?
No, something else? Some other answer?
From
What is
5 into
repeat?
5 raised to the power 3?
Yeah.
5 raised to the power.
Then what is this? If this is 5 raised to the power 3, then what is this?
This is 5 raised. Yeah, this is also. Yeah.
Repeated addition is multiplication. Somebody said 5 into 3. Repeated addition is multiplication. Repeated multiplication is written in the exponential form.
This is Aishwarya. I said 5 into 3.
5 into 3, yeah. See, repeated addition is multiplication. What is 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7? Some 50 times, 50 times. It's nothing but 7 into 50. Yeah, 7 into 50, which is 350. But 7 into 7 into 7 into 7, 50 times is written as 7 raised to the power 50. Repeated addition is multiplication. Repeated multiplication is written in the exponential form. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah, repeated addition is multiplication. Repeated multiplication is written in the exponential form. So now is this repeated addition?
Yes, ma'am.
Then
Yes,
yeah, then it's multiplication. Then how will you write it?
2, 3
Ma'am,
times.
2 into 3 raised to the power x.
2 into 3 raised to the power x, is it?
Mm.
How many times here? How many times?
Thrice.
3 times. What comes 3 times?
3 times 2x to the power
Yeah,
x.
so yeah, then how do you write that? 3 times 2 to the power x is what?
Ma'am, can I say
6x.
Yes.
3 plus 2 raised to the
2 to the
power.
power 3 to the whole power x?
2 to the power x and into 3.
Yeah. 2 to the power x into 3 or 3 into 2 to the power x. Both are correct. 2 power x plus 2 power x plus 2 power x. Repeated addition is multiplication. Is 2 power x into 3 or 3 into 2 power x. But if you had 2 power x into 2 power x into 2 power x, here we use the law of exponents.
It will become, yeah, we'll have to add the powers.
Powers, yeah.
But here 3 doesn't have a power. It's just getting multiplied. 2x is getting
Yeah.
multiplied twice.
Correct. So this one is multiplication. So now by the law of exponents, you need to add the powers x plus x, which is 2 to the power 3x. Or the other way, we understood when it's repeated multiplication, it's written in the exponential form. So 2 to the power x is happening 3 times. So to the power 3, which is again 2 to the power 3x only. Because when you have multiple powers, you'll have to multiply the powers. X into 3 is 3x.
Yeah.
Is equal to 192. So next step, 2 to the power x is equal to 192 by 3. 3 can come for division to the other side, correct? Now 2 to the power x is equal to, what is 192 by 3? 3 6 are 18, 1 carried over, 3 4s are 12. Now express 64 in base 2. What is 64 in base 2? Is it 2 square or 2 cubed or 2 to the power 4?
2 to the power 6.
2 to the power 6. What is 64 in base 4?
4.
What is 64 in base 4?
4 cubed.
4 cubed. What is 64 in base 8?
8 squared. 8 squared.
8 squared. Yeah. So 64 can be expressed in different ways. 64 in base 8 is 8 squared. 64 can be written as 2 to the power 6. 64 can be written as 4 to the power 3. 64 can also be written as 8 to the power 2. Now here we choose to write it as 2 to the power 6 because we have the base 2 on the LHS. Now at this point, you should say bases are same on both the sides. So equating the powers, we get x is equal to 6. At this point, you must say bases are same on both the sides. Okay, bases are same. Equating the powers, we get we get x is equal to 6. Is that clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, children. Please write down the question. You can continue with the question number. You don't have to write 8 and all that. You please continue with the question number. If your last question number is 15, then this is 16. Exponents are very, very important. This concept of exponents is is so much used in physics in your 11th and 12th standards also. You have to master this chapter. Please finish writing and let me know what you do.
Done, ma'am.
Yeah.
Done, ma'am.
Okay.
Done, ma'am.
Yeah, Chitu. Okay.
Done, ma'am.
Yeah. Let me quickly work it again. So the question is 2 power x plus 2 power x plus 2 power x is equal to 192. So on the left hand side, we have repeated addition, which is multiplication. So the term 2 power x is added to itself 3 times. So into 3. The term 2 power x is added to itself 3 times. 3 times means into 3 is equal to 192. So now 3 comes for division to the other side, 192 by 3. So the quotient 192 by 3 is 64. Now, since on the left hand side the base is 2, we also express 64 in base 2, which is 2 to the power 6. How do we find this? 64, 2, 32 times, 2, 16 times, 2, 8s are 2, 4s are 2, like this. So 64 is equal to 2 to the power 6. Now, bases are same on both the sides. Equating the powers, we get x is equal to 6. Very good, children. Next one. So on the left hand side, we have the same base 2 by 5. On the left hand side of the equal to sign, we have the same base 2 by 5. See here, what do you have? 2 by 5, the whole power 2x plus 6 into 2 by 5, the whole power 3 is equal to 2 by 5, the whole power x plus 2. Now look at the left hand side. See, whenever you have to simplify, you should simplify and then use that rule. Bases are same on both the sides, equating the powers. That rule can be used only when the LHS and RHS are completely simplified. The rule bases are same on both the sides, equating the powers. This rule can be used only when the LHS and RHS are completely simplified. So now the LHS needs to be simplified further. So what is the rule? Bases are same and it's multiplication. Add the powers. So write the base once and add the powers. 2x plus 6 plus 3 is equal to, write the RHS as it is. That's already simplified. Nothing can be done with the RHS. Now in the LHS we have 2 by 5 the whole power. 2x plus 9 is equal to 2 by 5 the whole power x plus 2. Now you see that the LHS and RHS are completely simplified. LHS is 2 by 5 the whole power 2x plus 9. RHS is 2 by 5 to the power x plus 2. Now the LHS and RHS are completely, RHS was already simplified. Now we've simplified the LHS. Now use the rule. Bases are same on both the sides. Equating the powers. Equating the powers. We get, equating the powers, we get 2x plus 9 is equal to x plus 2. See, on both the sides, you have the same base 2 by 5. So ignore the bases. Equate the powers. 2x plus 9 is equal to x plus 2. So how do you solve this? 2x minus x is equal to 2 minus 9. X is equal to minus 7. So the value of x is minus 7. X can be anything. X can be positive, negative. It can be 0. It can be a fraction. It can be a decimal, anything. X is equal to -7. That fine, children? Please write down.
Done, ma'am.
Yeah.
Mom, just 1 second.
All of you? Okay. Done, all of you?
Completed, ma'am.
Okay. We'll do all of these, children. I'm just trying to find something. Okay, fine. Okay, we'll do this one. It is must, yes, here. Yeah. We'll work this and wind up the session for today, children. Yeah, look at this question. 5 to the power, the given question is 5 to the power 2x plus 1 divided by 25 is equal to 125. This equation is given to us. With the help of this equation, we need to find the value of x, or we have to solve this equation to find the value of x. Okay. So now the next step will be 5 to the power 2x plus 1 divided by, like this, divided by what is 25? 5 square. What is 25? 5 square is equal to what is 125? 5 cubed. 5 cubed. 125. 5 25 times 5 5 times and 5 answer. So 125 is equal to 5 into 5 into 5, which is 5 cubed. Now cross multiply. 5 to the power 2x plus 1 is equal to 5 to the power 3 into 5 to the power 2. See, you can also use the law of exponents, and you can also do this. 1 minute, children. You can do either of this. Let me do it in both the ways. Let me do it in both. After this step, children, after the step, you can do it this way. Like its division, no? Bases are same and its division, so you can subtract the powers. So you can do it like 5 to the power 2x plus 1 minus 2, subtracting the powers. 2x plus 1 and 2 minus 2. Bases are same and its division, so subtracting the powers is equal to 5 cubed. If you do it like this, then 5 to the power 2x minus 1, because plus 1 minus 2 is minus 1, is equal to 5 cubed. Now you see that the LHS and RHS are completely simplified. The left hand side and right hand side are completely simplified. At this point, bases are same on both the sides, so equating the powers. 2x minus 1 is equal to 3. Ignore the base 5 on both the sides. So now 2x is equal to 3 plus 1, 4. X is equal to 4 by 2, which is 2. Or if you cross multiply, okay, is equal to 5 cubed into 5 square. So 5 to the power 2x plus 1 is equal to, bases are same, multiplication, add the powers, 3 plus 2. 5 to the power 2x plus 1 is equal to 5 to the power 5. 5 to the power 5, 3 plus 2 is 5. Now you see that the LHS and RHS, they are completely simplified. LHS, RHS separately. LHS is simplified. RHS is also simplified. You cannot do anything further with the LHS or the RHS alone. At this point, you should write that. Bases are same on both the sides. So equating the powers we get. Equating the powers. 2x plus 1 is equal to 5. The power 2x plus 1 is equal to the power 5. So 2x is equal to 5 minus 1. Plus 1 on the other side minus 1. So x is equal to 4 by 2, which is 2. So the value of x is 2.
Yes, ma'am. I did it the other way.
Okay, nice. Very good. All right, children. Let me just show you what I have uploaded in the portal. Aniston and Lakshana. Aniston and Lakshana. Yeah.
Yes, ma'am.
Yeah. I've shared your credentials on WhatsApp.
Yeah, ma'am. Yeah, I saw it.
Yeah, I'll now. So please see how you can access your portal and how you can find the assignments and exams. Okay.
Yes, ma'am.
Yeah. All of you, please stay in the meeting. Yeah. So, Lakshana and Ariston, you have to type the URL in the browser. Open your Chrome browser, whatever browser on your laptop or your device, and type Atharv, ATHARV dot testpress, TESTPRESS.in. All right, in the browser.
Yes, ma'am.
Enter. That will
Okay,
bring you to a page like this.
Okay, ma'am.
Yeah. Now here you have to enter your email and your username and password, not email. Username and password. I've shared that with you. Okay. Now I'm using a different one. So username, password. Okay.
Okay, ma'am.
So when you do that, it'll bring you inside the portal. Now, your portal will not have all these. Okay, it will not have so many contents. You will be able to see only these three. CBSE-VIII exams, CBSE-VIII library questions, and CBSE-VIII library answers. You will be able to see only these three. You will not be able to see the others.
Okay, ma'am.
Yeah. So when you log into your portal, you will see only these three. Exams, library questions, library answers.
Okay.
So now further you can explore. So in exams, you can see the exams which are available for you. But as of now, you can see the content, 0 chapter, 0 contents.
Okay.
Is it? Yeah, I've zoomed in now. Yeah.
Yes, ma'am.
Now let me take you to the library questions. So you can see the contents alongside here. Tap on that.
Okay.
So somebody's mic is enabled. Please disable your mic. Yeah. So now when you log in, when you tap on contents, children.
Okay.
No, Alison, you can disable your mic.
Okay, ma'am.
Yeah. Lakshana and Gayatri, since you both are new.
Ma'am?
Yeah, you're able to follow what I'm saying?
Yes, ma'am.
Okay. Yeah. So here you can see the two chapters, rational numbers and exponents and powers. So if you tap on the contents against exponents and powers, you can see I have uploaded some assignments. Okay, so you can see here exponents and powers, homework 1, homework 2, homework 3, and homework 4. So you must start working from the first one. So if you open the first homework, you can see ignore these dates, children. Ignore these dates. Don't be concerned about the dates here. So this is that I have named my file like that. So Ignore the dates. Now, when you come down, you can see the assignment here. You can see the questions. So this one has only one slide. Now the next question will be, should we write the questions? You have to write the questions. You have to write the questions. And then the next question is, when should we finish the assignment? What is the due date? You start working. We'll be discussing it. Well, no, I really cannot say, like when you should finish it. So maybe I'll just, so based on the assignment I've posted, maybe next Wednesday, we can see the answers to all these assignments. So you start working whenever you find time, make some, not whenever you find time, make time, make a timetable to work the assignments. So this is practice. You will be practicing with the help of the assignments. So you keep going steadily. So sometime when I feel, it is, I've given you sufficient time to complete all the homework, we'll discuss the answers. Yeah. So that's about the assignment, children. So now it's not that, you have given us so many assignments, we don't have time to do it. See, my work I've posted. You have to plan. It's not too much because I'm not asking you to finish it in a stipulated time. That's what I'm saying. So you make a timetable. I don't know your schedule. You may be into some other classes, your school timings. There are so many things, that is responsible for the amount of time you have to spend for the assignments I post. So I cannot make it hard and fast that, all of you should finish it by this date. I cannot give you a deadline. So you plan according to your schedule, your school, your extracurriculars, whatever. You work this consistently. So when I discuss the answers on a particular day, if you have worked it, you can check it with your answers. If you have not worked, you can learn the answers there and you can complete it later. That's how it's going to work here with respect to homework. So you can see homework too. If you tap on that, you can see the next homework. Yeah. So assignments you cannot do here. You can only view the questions here. You have to write the questions in your notebook and work the answers in your notebook. You cannot write anywhere here and submit your homework. You can only view the questions in the portal. But when it comes to exams, so you keep going behind, go back. You can see here, 8 exams. Can you see 8 exams? Tap on that. As of now, I have not uploaded any exams for you. Children, this is very important. Please listen. Are you all there?
Yes, ma'am.
Yes.
Yeah. So see
Yes,
here,
ma'am.
you should, you must tap on running. You must tap on running. You must tap on upcoming. So if any exam is running, that means it's already scheduled and you can take it up at any time. Upcoming meaning, supposing I've scheduled some exams for a future date. So maybe, like I've uploaded some 4 exams today and it's not available now. You can take it only the next Sunday. So you will see such exams in upcoming. You cannot take it now. Exams which are in upcoming cannot be taken up now. I have scheduled it for you to take it up on a later date. Running.
So that
If you
we
see,
can know the date when the exam will be.
yeah, exactly. So that you can plan. Yes, exactly. So that you can plan. So you know that, some exams are there for you on the Sunday. So you can plan your day accordingly. From there, it will be available for some days. If I schedule an exam for, say, the coming Sunday, it's not mandatory that you finish all the exams on the same day. At least a week's time will be given to you from there. So I will not end the exams till all of you finish it. But at the same time, all of you should not be negligent. You have to be responsible and make sure that you finish it at the earliest. there will be a minimum of a week's time. So supposing you see some 4 exams under running today, from today there'll be at least a week's time. You can take it up any time within that week. I will not end the exams unless all of you complete it. And if you see some exams under running, doesn't mean that you should take it today itself. You can take it up any day, but once you start the exam, you have to finish it. So once you start the exam, the timer will begin. And supposing that exam is for 45 minutes, the timer starts. And at the end of 45 minutes, the exam will be submitted. Then you cannot take it up again. If you don't start the exam, you can take it on any day. You can postpone it by a day or 2 or 3 days, 4 days. You can postpone it. You can take it whenever you want. But once you start the exam, the timer begins. And if that particular exam is for 45 minutes, the timer starts. And at the end of 45 minutes, whether you have finished or no, the exam will automatically end. If you finish it in less than 45 minutes, you will have to say submit exam. You will see all the tab. It's, like very user friendly. You will know what to do next. If you finish it before the scheduled time, you will see that button submit exam. So you submit it. But supposing you even past 45 minutes, you don't finish the exam will automatically end. And whenever you take an exam, make sure that you have meaning active internet connection. Supposing you are expecting a power failure or something that day, and you take up an exam and the power fails and the internet fails, the exam ends. You cannot do it again. In the middle of an exam, if you lose the internet connection, the exam ends. The second the internet connection is lost, the exam ends. And you cannot see it again. You cannot take it up again. So keep all this in mind, children, before you start the exam. All right?
Yes, ma'am.
Yeah. And the questions are not simply randomly got from somewhere and put it. The questions are, like based on I prepare the exams, keeping in mind whatever concepts have been taught you in the class. There can be no question in the exam away from what I've taught you. So you need to go through the contents of the classwork, whatever you've learned in the class so far till exponents. You should have revised that, practiced that, completed the assignments in order to take up the exam. So don't be in a hurry to take up the exams. Only if you have practiced, you should first, like revise all that you have learned in the class. And then work a couple of assignments to, feel confident to check if you really have understood things clearly. Assignments you do by yourself, right? In the class, I'm talking and you just have to say, yes, yeah, I understood. You're not actually thinking. You're just taking whatever I say. But when you do an assignment, you think, your thought process is activated. So it's then you realize what is clear to you, where you have a doubt, where you need to reach out to me and get it clarified. You realize so many things when you do an assignment yourself without anybody's help. So completing assignments is very, very important. It's a very crucial part of learning. So please do your assignments and then take up the exams. Don't be in a hurry to take up the exams. I told you there is no end time actually. I normally don't end the exams. So it's available for you till you complete it. But the only thing is don't be lethargic. Don't, like make that a disadvantage for you. Let you not postpone that under the pretext that it's always there. So chalo, let me do it anytime. Don't do that. Yeah, so that's about the portal, children. So assignments are available on Exponents. So you can try them. And assignments will always be there. It's not that once you open the assignment, you cannot see it again. It's always there. You can always go back there and, find the questions. All right, children. So any more any doubts you have related to the portal, please text me on WhatsApp or send a voice note. I'll help you. I don't think you should have any, but in case any, you can definitely ask me. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Good night, ma'am.
Thank you, children.
Ma'am, and could you send me that recording of rational numbers?